Okay, we're finally live. We had some technical difficulties getting started. We'll be in section 9.5 again today, looking at some of the word problems. So we're on number 5. The area of a rectangle is 75 square feet. Its length is 2 more than 3 times the width. Find the length and width of the rectangle. In general, we know that the area of a rectangle is length times width. And we're given information about a rectangle. The area is 75 square feet. And the length is described in terms of the width. The length is 2 more than 3 times the width. So since the length is described in terms of the width, my general strategy in a case like this is to pick a variable to represent the width. So the width is x feet, and the length is 2 more than 3 times x, because x is the width. 2 more than 3 times the width is 3x plus 2. 2 more than 3 times the width. And then just multiply length times width. 3x plus 2 times x equals the area 75. And here is our equation. The equation is a quadratic equation. We can get it into standard form. First multiply 3x plus 2 times x to get 3x squared plus 2x equals 75. And then in standard form, subtract 75 from both sides. We get 3x squared plus 2x minus 75 equals 0. Okay, we can solve this equation using the quadratic formula. So let's practice the quadratic formula. So hopefully you have that memorized, the quadratic formula. X equals negative b plus and minus the square root of b to the second minus 4ac, all divided by 2 times a. So for this one, a is 3, b is 2, and c is negative 75. Okay, so x equals negative 2, that's the negative b part, plus and minus the square root of 2 to the second minus 4 times 3 times negative 75. And this is all divided by 2 times 3. And we get x equals negative 2 plus and minus square root of a number all divided by 6. Inside the square root, 2 to the second is 4. And we are subtracting 4 times 3 times negative 75. So we're subtracting a negative. That means we're adding 12 times 75. Which is 900, isn't it? Yeah. So notice that the solution we get from subtracting is negative, and in the context of the problem, the width and the length are not going to be negative. So we can ignore the minus sign, and then x equals negative 2. Sorry, this is plus 900. negative 2 plus the square root of 904, all divided by 6. Okay, so what's the square root of 904? Well, 4 is a factor. So 4 times 226 . So let's write this as negative 2 plus, and then the square root of 4 is 2 times the square root of 226, all over 6. Okay, so the numerator and denominator have a common factor of 2. So when we cancel the common factor of 2, we get x equals negative 1 plus the square root of 226 divided by 3. Okay, so it's possible to get decimal answers for these kinds of problems. That's more apt to happen in the real world anyway. Okay, let's look at problem number 6. This one, the height h in feet of a projectile shot upward is given by this equation. H equals negative 16t to the second plus 80t plus 96 after t seconds. Find the number of seconds it takes for the projectile to hit the ground. Okay, the h is the height of the projectile t seconds after it's fired upwards. And so when the projectile hits the ground, the height will be 0. So that is the key observation in this one. When the projectile hits the ground, the value of h is 0. So replace h with 0 in the equation and then solve for t. And so we'll get 0 equals negative 16t to the second plus 80t plus 96. Okay, what would you do if you want to solve this for t? What would be your next step?
I would use the quadratic formula. I've already put in the.
Okay, you want to use the quadratic formula? You have that option. So if you use the quadratic formula on this equation, then a is negative 16 B is positive 80, and C is 96. But I'll take this opportunity to suggest another thing that can be done that will make the process simpler. Notice that all of the numbers are divisible by 16. 16 goes into 80 5 times, and 16 goes into 96 6 times. And then another thing, since we're starting out with a coefficient of t squared that's negative, if we divide every term on both sides of the equation by negative 16, in my opinion, that will make the arithmetic simpler than if we just divided every term by positive 16. Okay, so divide both sides by negative 16. 0 divided by negative 16 is 0. Then negative 16 t to the second divided by negative 16 is t to the second. 80t divided by negative 16 is negative 5t, so here we write minus 5t. And 96 divided by negative 16 is negative 6, so we write minus 6. I don't know about you, but solving this equation looks like it's going to be simpler than the one that it came from. The solutions to the two equations are exactly the same, but without the bigger numbers, the arithmetic will be simpler. Okay, so if we use the quadratic formula on this one, A is 1, B is negative 5, and C is negative 6. So we write T equals the negative of negative 5 plus and minus the square root of the number negative 5 squared minus 4 times 1 times negative 6, all divided by 2 times 1. The negative of negative 5 is 5. And then plus and minus the square root of 25 minus 4 times 1 times negative 6. So we're subtracting negative 24. That's the same as adding 24. Dividing everything by 2. In this problem, t is measured in seconds. So the negative answer, the one we get by subtracting, won't make any sense. So we'll just pick the solution we get by adding 5 plus the square root of 49, all divided by 2, or 5 plus 7 divided by 2. 5 plus 7 is 12. 12 divided by 2 is 6. So it would take 6 seconds after the projectile is fired upwards for it to hit the ground. An alternative, so oftentimes we have more than one way to solve an equation. We can solve this one by factoring. If 0 equals t to the second minus 5t minus 6, one factor is t minus 6, and the other one is t plus 1. This equation has two solutions. One is positive 6, the other one is negative 1. But in this problem, the solution that makes sense is the positive solution. So it might be worth noting the different options that you have in solving an equation. Some are just easier, even when we're down to 0 equals t to the second minus 5t minus 6. It looks a little easier just to solve it by factoring than to use the quadratic formula. Okay, let's move on to the next page. This one says a pole perpendicular to the ground casts a shadow whose length is 1/3 the height of the pole. The distance from the top of the pole to the edge of the shadow is 20 feet. Find the height of the pole and the length of the shadow. I know what you're thinking. You're thinking, well, I can just measure the length of the shadow. So how could I possibly know the distance from the top of the pole to the edge of the shadow? Well, this is just an exercise, in setting up equations. A lot of the problems, when you think about them, you probably wouldn't do in practice, but we're just learning how to set up equations and solve them. Well, drawing a picture might help. A pole is perpendicular to the ground. That means it forms a right angle. And it casts a shadow that is 1/3 the height of the pole. So the sun is in the position that it casts this shadow of however long it is. And we're told that the shadow is 1/3 the height of the pole. And the distance from the top of the pole to the edge of the shadow is 20 feet. So what do we have here? What sort of problem is this? Or what does it involve? Yeah, it involves a right triangle and information about the sides of the right triangle. So using the Pythagorean Theorem is going to help us. Okay, so we're told that the length or the distance from the top of the pole to the edge of the shadow is 20 feet. So that is the hypotenuse of the right triangle. And we're told that the shadow is 1/3 the height of the pole. So this is the height of the pole and the shadow length. Okay, so let's make variable assignments for the height of the pole and length of the shadow. There's more than one way to do it. If we say the height of the pole is x feet, and then we're told that the shadow is 1/3 the height of the pole, so if the height is x feet, the shadow is 1/3 times x feet. So if you label a new right triangle, x is one side, 1/3 x is the second side, and 20 is the hypotenuse. And then use the Pythagorean Theorem. If you have a right triangle, if you square the length of the hypotenuse, that's equal to the sum of the squares of the lengths of the two legs. So c squared equals a squared plus b squared. Okay, so for this right triangle, make sure you're careful when you're squaring. We have to square x. Then we have to square the term 1/3 x, and then that's equal to 20 squared. Okay, then x squared, what do we get when we square 1/3 x? 1/9
x squared.
Yeah, 1/9 x squared. And 20 squared is 400. On the left-hand side, these are like terms. So x squared plus 1/9 x is how much when we add x squared to 1/9 x squared?
1/9 x to the fourth.
Now, these are like terms. So another way to think of this is x squared plus x squared over 9. The least common denominator is 9. So multiply x squared over 1 by 1 in the form 9 over 9. So 9x squared over 9 plus x squared over 9 equals 400. And then 9x squared over 9 plus x squared over 9 is 10x squared over 9 equals 400. Then multiply both sides by 9, so we get 10x squared equals 3600. And then we can divide both sides by 10, and we get x squared equals 360. And then we can just take the positive square root of 360 for x. X equals the positive square root of 360. The largest factor of 360 that's a perfect square is 36. 36 times 10 is 360. So this is the square root of 36 times the square root of 10. And finally, x is 6 times the square root of 10 feet. Okay, so the height of the pole is 6 times the square root of 10 feet. The shadow is 1/3 x. So where should I write it? Up here we'll write the pole height. The pole height is x equals 6 times the square root of 10 feet. And the shadow length is 1/3 x. And 1/3 of 6 times the square root of 10 is 2 times the square root of 10 feet. All right, the next problem. So I'll give you a heads up. Even though this is the last problem on the lecture notes that I sent you, I did write 2 more problems in the event that we run out of time, or I mean, if we run out of work before we run out of time, which that looks like that's going to happen. So after number 8, we'll have a couple more problems to look at. Okay, but this one, the height h in feet of an arrow shot upward after t seconds is h equals negative 16 t to the second plus 320 t. This one says find the number of seconds it takes for the arrow to be at a height of 400 feet. Okay, so how do we begin on this one? We want to find the number of seconds it takes for the arrow to be at a height of 400 feet. Well, let's answer this question first. How high above the ground is the arrow at the instant that it's shot upwards? Yeah, 0. At t equals 0 feet, the height is 0 feet above the ground. So if the arrow is shot high enough, then there will be 2 different times when the arrow is 400 feet above the ground. Once on the way up and a second time on the way down. See what I mean? So that's assuming that 400 is in the range. So if the arrow is shot upwards and then comes back down, then on the way up it is at 400 feet, and then also on the way down. So we're going to expect 2 answers, 2 legitimate answers. One when the arrow hits 400 feet on the way up, and second, the number of seconds it takes for it to be at 400 feet on the way down. Okay, so h represents the height. So to solve this equation, we replace h with 400, and we get 400 equals negative 16 t to the second plus 320 t. So we want to solve this equation for t. How would you proceed from here?
Subtract 400 from both sides.
Okay, yes, make one side 0. So if we have 2 ways to do that. We can subtract 400 from both sides, so we get 0 equals negative 16 t to the second plus 320 t. Or we can add 16t to the second and subtract 320t from both sides. So two ways to do it. I'm going to add 16t to the second to both sides and subtract 320t, and then plus 400 equals 0. Okay, now what?
Divide by 16.
Yeah, every one of those numbers is divisible by 16. So if we divide every term on both sides of the equation by 16, we'll get another equation, and the numbers will be smaller and consequently easier to work with. So divide every term on both sides by 16. 16t to the second divided by 16 is t to the second. Minus 320t divided by 16 is minus 20t. And 400 divided by 16 is how much? 25. Okay, now what? This is a quadratic equation in the variable t. So if we use the quadratic formula, a is 1, b is negative 20, and c is positive 25. Okay, what should I write next?
Negative 20.
Okay, so that was a trick question. The variable is t. So we write, the very first thing we write, t equals. And then the quadratic formula, well, the t equals is part of the quadratic formula. So t equals the negative of negative 20 plus and minus the square root of the number negative 20 squared minus 4 times 1 times 25, all divided by 2 times 1. And then 10 equals positive 20 plus and minus the square root of a number, all divided by 2. Inside the square root, we have negative 20 squared, which is 400. And then we're subtracting 4 times 1 times 25, we're subtracting 100. So t equals 20 plus and minus the square root of 300. The square root of 300 can be simplified. 100 is a factor of 300 that's a perfect square. 100 times 3 is 300. So we can write this as t equals 20 plus and minus 10 times the square root of 3, all divided by 2. So what next?
Divide everything by 2.
Yeah, every factor in the numerator, 20 and the 10 times the square root of 3, has a common factor of 2 with the denominator. So we write this, after we cancel the common factor of 2 from all of the terms, we get t equals 10 plus and minus 5 times the square root of 3. The smaller solution for t is t equals 10 minus 5 times the square root of 3. So this is positive. 5 times the square root of 3 is about 8.5, right in that range. So at about approximately 1.5 seconds, the arrow will be at 400 feet on the way up. But then on the way down, the arrow will be at 400 feet at t equals 10 plus 5 times the square root of 3 seconds. Okay, I do have 2 more problems. So on extra paper, you can write down this first problem. This one says it took John 1 hour less to travel 36 miles than it took Paul to travel 28 miles. John's speed was 5 miles per hour faster than Paul's speed. Find John's speed and Paul's speed. Hey, this is uniform motion, so equations have the form rate times time equals distance. In the last sentence, it tells us find John's speed and Paul's speed. So we'll pick variables or give variable assignments for John's speed and Paul's speed. So how do we do that? Well, in the second sentence, we're told that John's speed was 5 miles per hour faster than Paul's speed. One option, if I pick x to be Paul's speed in miles per hour, and if John's speed was 5 miles per hour faster than Paul's speed, then John's speed will be represented by x plus 5 miles per hour. Okay, and what next? So rate times time equals distance. For now, we have the rates or the speeds assigned in variables, x plus 5 miles per hour for John's speed and x miles per hour for Paul's speed. What do we know about time?
So John 1 hour less to travel 36 miles than Paul traveled 28.
Yes, we're told that it took John 1 hour less to travel 36 miles. That's the distance. Than it took Paul to travel 28 miles. Okay, so all of the components are there. So let's pick T sub j for John's time. And T sub p for Paul's time. So in an equation, how do we relate John's time and Paul's time? So John took 1 hour less than Paul. So we could write John's time is less than Paul's time by 1 hour. And we can convert this into an equation, which will be useful in a couple of minutes. There's 4 ways that we can use this inequality and convert it into an equation. I guess my preferred option is to subtract the smaller number from the larger number and set it equal to 1. So in other words, Paul's time minus John's time is 1. And then just check to make sure it makes sense. John took 1 hour less than Paul. Okay, so let's go ahead and write a rate times time equals distance equation for John. John's rate is x plus 5 miles per hour. And in T sub j, in that amount of time, John traveled 36 miles. And then for Paul, write down rate times time equals distance for Paul. Paul's rate is x miles per hour. And in T sub p hours, Paul traveled 28 miles. Okay, what do we do next? We want to know what x is, and if we know what x is, we'll know what x plus 5 is. So we need an equation whose only variable is x. So how do we get there from here? We're going to use these 3 equations. Paul's time minus John's time equals 1. This equation for John, the rate times time equals distance, and this equation for Paul, Paul's rate times time equals distance. So if we solve this equation for John's time, T sub j is 36 divided by x plus 5. And then in Paul's equation, solve for his time, T sub p equals 28 divided by x. And then substitute those into this equation. Paul's time minus John's time is equal to 1. So Paul's time minus John's time equals 1. So we finally have an equation whose only variable is x. Multiply every term on both sides by the least common denominator, which is x times x plus 5. When we multiply x times x plus 5 times 28 over x, the x's cancel, and we get 28 times the binomial x plus 5. And then when we multiply 36 over x plus 5 by x times x plus 5, the x plus 5 factors cancel, so we get minus 36x. And on the right-hand side, 1 times x plus 5 is x times x plus 5. Hey, then we have a quadratic equation. So 28 times x plus 5 is 28x plus 140, and then minus 36x equals x squared plus 5x. On the left-hand side, we get 140 minus 8x equals x squared plus 5x. And if we make the left-hand side 0 by subtracting 140 and adding 8x, we'll get x squared plus 13x minus 140 equals 0. This one can be solved by factoring, but we are out of time, so you can at least use the quadratic formula, but you can also solve this by factoring. Okay, go ahead and sign in for attendance.
Thank you.